pin photodiode. So where any optical communication, you type in Google optical communication system receiver. இது டைப் பண்ணீங்கன்னா the first thing which will come to you the in search is photodiode, because photodiodes are devices which are able to detect light and produce voltage or current proportional to the amount of light detected. So see the definition. A pin photodiode is used for detection of light at the receiving end in the optical communication. So photodiode is used as a receiver. Which devices can be used as transmitters? Which device can be used as transmitters in optical communication? And the device which will give light, what are those devices called as? You studied, you know the basics. I'm telling photodiode is used as a receiver because photodiode will convert light into electrical signal, voltage or current. But இது வந்து receiverல. So transmitterல I want a device which converts voltage or current into light. So give me examples of such devices. You studied in physics all this. Which device converts voltage or current into light? Which diode converts that? Which diode?
Light emitting.
Yes, light emitting diode, LED, very good. And LED கூட இன்னொரு இதுவும் வரும். That is very popular now. What is advancement of LED? LED க்கு அடுத்தது என்னது சொல்லுவோம் நம்ம? Which also emits light. You have in all your keychains. When you press that, you get a highly focused beam of light. Laser, very good. So optical, remember, transmitter, you will have LED and laser. Receiver, you'll have only one device called as photodiode to convert the light into electrical pulse. See, conventionally, we have so many methods of communication. Analog communication, digital communication, optical communication. So, nowadays, optical communication is getting popular because optical offers enormous speed. You know the velocity of light, 3 into 10 power 8 meters per second. So, on the speed, if you're going to send data from one point to another, then you can send huge amount of data. So, if a conventional or a companies, Airtel, they are giving fiber data. ActNet ஒரு company இருக்கு, they are giving fiber. Why everybody is focusing on fiber? Because enormous amount of data can be uploaded or downloaded. But அதுக்கேற்ற மாதிரி cost will also be high because you are using high-end technology. ஒரு அபார்ட்மெண்ட்ல 50 பேர் இருக்காங்க அப்படின்னா ஒருத்தர் ஒண்டி ஆக்ட் யூஸ் பண்ணாருன்னா the cost will be very high. But in the apartment, like 50 பேருமே, if they are willing to go for an ACT connection, then the cost will be very much reduced because fiber வந்து நீங்க தனியா யூஸ் பண்ணீங்கன்னா it is costly because you have to bear the entire cost. But அதே if you are going, if multiple people are using the same connection, then the cost will be reduced. See, உங்க ultimate whether you are using it individually or you are using it as a group, only a single fiber is going to come to your apartment. அந்த சிங்கிள் ஃபைபரை வந்து ஒரே ஒரு சிக்னல் போனோமா இல்ல 100 சிக்னல் போனோமாங்கிறது we have to decide. Only when many people use the fiber, the cost is going to be reduced. Okay, so the optical communication is very, very popular nowadays. So this pin photodiode plays a very, very crucial role in detecting the optical signals. And remember, this pin photodiode will going to work in a reverse bias. See, in optical communication, all the transmitters, LED, laser will be working in forward bias. All the receivers, pin photodiode will be working in reverse bias. Transmitters forward bias, receiver reverse. R for R. In optical communication, all the receivers will be operating in a reverse bias voltage. So as I told you, pin la 3 layer irukku, P intrinsic, N layer, and it's a reverse bias diode. So you have an intrinsic layer. You have an intrinsic layer which is between the heavily doped P and N type semiconductor materials. See the diagram. I have a P region, I have an N region, and I have an I region. And this P and N are heavily doped. Naduvula I have this intrinsic region, and I told you it is operated in reverse bias. Reverse bias, the P will be converted to negative, N will be converted to positive. So the depletion region will be covering the entire intrinsic region of your diode. So you know in reverse bias, the depletion region is very, very wide, right? So this depletion region is going to occupy the entire intrinsic region of your diode. And I'm going to focus light on P region of my device. and I'll be getting a current flowing from the N region, which is proportional to the amount of light incident in the P region. Okay. So see here, the depletion region extends almost to the entire intrinsic layer where most of the absorption of light takes place. So the width of intrinsic layer is large compared to the width of the two layers. நீங்க பார்க்கலாம், when you compare P and N, intrinsic region is very, very large because it has to accommodate the depletion region which is formed in reverse bias. So since the intrinsic region is large, it allows the large absorption of light. Okay, so when light photons are incident on the pin photodiode, it generates electron hole pairs. So when light is going to be incident on the P region, electron hole pairs are generated. And you know these electron hole pairs, electrons already for P I am giving a negative. So electrons will be pushed into the depletion region. Okay, so these charge carriers present in the depletion region drift under the influence of existing bias so that it set up the reverse bias. You know already I am giving a reverse bias to the circuit, and since this light is going to have enough amount of energy, these charge carriers will cross the depletion region very easily, giving rise to the load current. That load current is given by a special name called as photocurrent. The current produced because of light. Normal current is produced because of voltage. When current is produced because of light, it is called as photocurrent. So a photodiode produces photocurrent. And the even though you can ask in reverse bias, you can say the current will be zero in a diode. In reverse bias, externally I'm giving energy to the electron in the form of photons, light, which is going to have more energy than the reverse bias voltage for the charge carriers to cross the depletion region. So in your name, they have used the charge carriers will drift. Drift na, they will cross the junction very fast because I have a very high reverse bias voltage setup. This reverse bias voltage will be setting up an electric field across the P and N regions. So drifting in diffusion or drift, in any PN junction diode, you'll have drifting and diffusion, but in the drifting is very fast because of the large electric field presence. So drifting is very fast, and the electrons will cross the junction fast. So the time taken by the electrons to cross the junction is very fast. So the response time is very quick. So these photodiodes will respond to light very quickly. Okay. So large width of the depletion region will help in absorbing more amount of light, thereby helps in achieving the very high quantum efficiency. See, if 100 photons are coming, only if I produce 100 electrons, the efficiency is 100%. If 100 photons are coming, I am producing only 10 electrons, then the efficiency is 10 by 100 only. So if I want to ensure that I absorb all the photons, I need to make my intrinsic region as large as possible. So adhukada, I am increasing the width of the intrinsic region to increase the quantum efficiency. P and N region are made smaller to ensure that drifting happens very quickly. So when electrons are going to drift very quickly, the time taken by the electron, the transit time is very, very small. When the transit time is very, very small, it responds quickly to the applied light. Okay. So you see here electric field distribution. So electric field is peak in the intrinsic region. And on both sides, you see it starts reducing. The electric field stronger, the charge carriers, after acquiring the excess energy from the electrons from the light, they cross the depletion region very quickly and reach the other end, contributing to what is called as photocurrent. So the current is named as photocurrent because it is produced as a result of light. Normal current is produced as a result of voltage. This current is produced because of the light being made to fall on the P region. This is called as a photocurrent. So photodiode produces a photocurrent, and you need to remember in three important things in pin photodiode. One is the three layers are there, P, I, and N plus, and I region is the width is going to be larger compared to P and N. Second point, pin diode is going to operate in a reverse bias. Third point, the current produced by the pin diode, which is proportional to the incident light, is called as photocurrent. Okay, these 3 points you have to remember in